Hi folks, it's the Math in a Minute lady, and today we're going to be looking at multiplying binomials. This is the full-length explanation. Look for Math in a Minute. If you want the 60-second quick blurb about this, look for the short video, but this one will go through in more detail what it means to multiply binomials. This would be an Algebra 1, potentially a pre-algebra concept, maybe also in Algebra 2. If you're still working on multiplying binomials, you might find this helpful. So that's the context. Multiplying binomials. And what do we mean by that? A binomial is a group of two things. Like bicycle has two wheels, right? So a binomial is a group of two things. We've got a set of parentheses here with two things in it, an x and a 3. That's the binomial. I have another one, an x and a 2. And I'm multiplying them together when there is no symbol in between parentheses. When you see parentheses, it means multiply. So when there's no symbol in between those two, the operation that I'm asked to do here is multiplication. And this is a very classic kind of a problem. You probably see this on whatever your state is, whatever state standardized test you take. They're all over this thing. This concept is also a big one if you go forward in math. It's really important that you know how to multiply binomials really quickly, and that's a fluid concept for you. So here, we're going to multiply x plus 3 times x plus 2. Now, you know the distributive property already. If I said, I don't know, 7 times x plus 2, you'd probably do that in your sleep. You know you take 7 times x and 7 times 2, and you add those things together. Now, I'm going to claim that this x plus 3 times x plus 2 is exactly the same kind of thing, but what I'm multiplying, let me make this one green and this one blue. What I'm multiplying the x and the 2 by now is x plus 3. I'm going to take x plus 3 times x and x plus 3 times 2. Do you see how that's really the distributive property? Whoop, whoop. And I'm going to add those things up. But now in each one of these things, I've got the distributive property happening again. X times x is x squared. 3 times x is 3x. Just going to add this. This is that same plus sign. 2 times x is 2x. 2 times 3 is 6. And you'll notice that essentially what I'm doing is everything in this set of parentheses gets multiplied by everything in this set of parentheses. The x gets multiplied by the x, and the x gets multiplied by the 2. The 3 gets multiplied by the x, and the 3 gets multiplied by the 2. And in the end, I have a whole bunch of terms. I have an x squared term. I have a term that has no x's in it at all. And you usually end up with two terms in the middle that both have one number and one x. Now, we're not 100% done here because those two terms in the middle that each have one number and one x, I'm allowed to combine those, right? 3 x's and 2 more x's makes 5 x's total. So my final answer here would be x squared plus 5x plus 6. I'm going to point out here, I'm going to just write this up here. This equaled x squared plus 5x plus 6. The goal here was to take the stuff inside the parentheses and have a final answer that does not have any parentheses in it. And you might notice that 6 was 3 times 2. And 5 was 3 plus 2. And that is not a coincidence. So if you saw the little quick video, you already learned these two kind of strategic methods that we have to make sure if you give me two binomials to multiply by, and you say, multiply these binomials, there's kind of two strategies to organize your thinking to make sure that you're multiplying together all the things that you need to. The first is this sort of window pane kind of looking thing, this box with all of the squares in it. I took my first binomial, x plus 3, and I wrote it on the side, one spot here for x and one spot for 3, and then x plus 2 is the other one, x plus 2. It doesn't matter if they're all the same width or not. It really doesn't. I kind of tried to draw them to scale here, but again, it doesn't matter. And I'm just going to fill in each box. Like this box was x this way and x this way. I'm going to fill it in with what would happen if I multiplied those two things together. X squared. This box over here is a 2 and an x. 2 times x is 2x. 3 and x together makes 3x. And then the last one is going to be 3 and 2 together, and that makes 6, and I add those all up. Combine my middle terms, and I get x squared plus 5x plus 6. Multiplying to fill in the boxes, then add together the things that are in the boxes. Just for funsies, let's try another one of those real quick. This is the first method for multiplying binomials. Let's say I asked you to multiply x plus 9 times x plus 7. Okay. X plus 9. X plus 7. X times x, x squared. 7 times x, 7x. 9 times x, 9x. 9 times 7, 63. Oops, I almost wrote 6x. My final answer would be x squared plus 7x plus 9x plus 63. Multiplied to fill in the boxes, add together the stuff in the boxes. Final step is that 7 x's and 9 more x's makes 16 x's. X squared plus 16x plus 63. And again, you will notice my final term here was 9 times 7, and my middle term was 9 plus 7. Not a coincidence at all. The second method we have for kind of organizing our thinking in this multiplication thing to make sure we're keeping everything straight is what we call the FOIL method. FOIL is an acronym, stands for first, outside, inside, last. So in this multiplication example that I had, the firsts would be x and x, like at the beginning of the parentheses. The lasts are the 3 and the 2. The outsides, the two numbers or variables that are on the very outside of my parentheses are an x and a 2, and the insides are 3 and x. So firsts, x times x is x squared. FOIL. Outside, x times 2, 2x. Inside, 3 times x is 3x, and lasts, 3 times 2 is 6. Combine my middle terms, x squared plus 5x plus 6. I'm going to say 99 times out of 100, if you're given 100 of these problems to do, in 99 of them, you will be able to combine the middle terms. I hesitate to say that you can always combine the middle terms because I can come up with a few examples where you can't. But by and large, you're going to be able to combine those middle terms. And what teachers will typically expect, if they give you a problem like this that has 2 binomials multiplied together, they're going to expect an answer that has some number of x squareds, some number of x's, and then a constant. That's like the pattern for how they look. And again, 99 times, well, maybe 9 times out of 10, the last number is 3 times 2, and the middle number would be 3 plus 2. So let's try an example here. I'm going to do the FOIL method on this guy. First, x squared. Outside, very front and very back, would be 3x. Inside, last. 3 times 5 is 15. Add them all up. 3 x's and 5 x's makes 8 x's. And this is my final answer, x squared plus 8x plus 15. Cool. Now, that's the basics. There are a couple of weird things to consider. We want to talk about coefficients and negatives. What happens if we have coefficients, a number in front of one or both of those x's? And what happens if we throw some negatives in here? Now, the negatives, we're going to attack those first, and actually nothing happens at all. We're going to treat this exactly the same way as we always did, remembering that x minus 6 is like saying x plus negative 6. So whenever I consider that 6, the negative is going to hang on it. So let's do this one with the window panes. Boop, 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 boop. I've got an x, I've got a negative 6, and an x, and a positive 2. Notice I would normally write the minus like x minus 6, but I really want to make sure that the negative is stuck to that 6. X times x is x squared. X times 2 is 2x. Negative 6 times x is negative 6x. And negative 6 times 2 is negative 12. I get x squared. Let's combine these right away. We're getting pretty quick with this. Negative 6x plus 2x's. That makes negative 4x. So x squared minus 4x minus 12, final answer. And I will notice again that negative 6 times 2 is negative 12. That was my final thing. And negative 6 plus 2 was negative 4. And that's my middle term. That when you don't have any extra coefficients, that rule of thumb always, that pattern always applies. Here's one with 2 negatives. I'll do this one first, outside, inside, last, and thinking in my brain, x plus negative 5 times x plus negative 4. Firsts, x squared. Outsides, negative 4x. Insides, negative 5x. Lasts, it's negative 5 times negative 4. You probably remember that a negative times a negative is a positive. Now, when I combine these middle terms, I'm going to get negative 9x. So my final answer is x squared minus 9x plus 20. So we've managed to deal with negatives. Awesome possum. Now what happens if we have a coefficient? Here I've got a 2 in front of this x. And again, not much really changes here. Choose the method that you like. If you like the window panes, usually visual learners tend to like that window panes method. Algebraic or linear thinkers tend to like this FOIL method. Whatever works for you, you do it. This is my firsts. I'm going to do FOIL again. 2x times 2 is 4. Oop, oh my gosh. Silly Mrs. Thomas. 2x times x is 2x squared. That's what you got to watch out for when you have these coefficients. The 2 times the x times the x. This 2 doesn't do anything but just hang on. X times x is still x squared, and I get 2x squared for my first. Outside, 4x. Inside, 1x. I'm going to call that 1x. You might want to just call it x. That's up to you. I'm going to call it 1x to make sure that I don't screw myself up when I'm combining my middle terms here. And then 1 times 2 is 2. Final answer, 2x squared plus 5x's plus 2. And you will notice now that we have this coefficient in the front of one of these numbers, that whole multiply the last numbers together to get the last number, that's okay, but add the middle two. 2 plus 1 is not 5, so I can't do the trick of like 2 plus 1 to get the middle thing. Sweet. All right. I don't think we need to do another practice of one of those. But there are a couple special cases I also want you to be aware of. Difference of squares is one, and binomial squares is another. A difference of squares, by that I mean, let's take my favorite number is 8. So what if I had x plus 8 times x minus 8? We're going to go about this the same way that we did in all of the previous examples, but I want you to be aware of what happens and what the answer looks like, so that when you're on the flip side of this, when you're factoring, when you're given something that's already multiplied out and you're asked to like reverse engineer, what were the binomials that multiplied together to be that? And that's called factoring. When you're in that process, it's going to be important for you to remember this pattern and what it looks like. Okay, so x plus 8 times x minus 8, just for giggles, let's say I had the same number, one was plus and one was minus, and I'm going to go ahead and do this one, x plus 8 and x minus 8 window pane wise. X times x is x squared, x times negative 8 is minus 8x, 8 times x is positive 8x, and then 8 times negative 8 is 64, x squared minus 8x plus 8x minus 64. And do you notice what happens here? Those guys just cancel out completely. I get 0 x's, and it's like that middle term disappears entirely. So that's going to happen. Here are a whole bunch of examples. Like if I had x plus 3 times x minus 3, x squared minus 9. It's always minus. This is always a negative because I've got one positive and one negative number in there, and a positive times a negative is a negative. It's always a square. 9 is 3 times 3, right? 7 times 7 is 49. So I always get this minus the square, difference of squares. And then the thing at the beginning is whatever your variable or that first expression was squared. And all the examples that we see here, y plus 10, y minus 10, y squared, minus 100. I just had one single variable out in the front, but I want you to be aware that it can happen. That's binomial squares. Let's say I had 2x minus 3 times 2x plus 3. I can still do this process if I don't just have x, but notice that they both have to be the same. So I can't have 2x and x and still kind of follow the pattern, but 2x and 2x is going to work here. 2x squared is 2 squared times x squared, or maybe you think of this as 2x times 2x, 2 times 2, x times x, 4x squared, 4x squared, middle terms will cancel out, and then minus 9. Last quick pattern here to be aware of is binomial squares. By this I would mean, what if I asked you to do x plus 5 times x plus 5? And I noticed that we know what squared is, right? Like if I said 3 squared, it means 3 times 3. If I said triangle squared, it means triangle times triangle. If I say x plus 5 squared, it means x plus 5 times x plus 5. So this square on the outside of the parentheses, I can't just sprinkle it in like the distributive property. This is not x squared plus 5 squared. I'm going to erase that before my computer bursts into flames. Oh, my word, that was so wrong. Okay, it's x plus 5 times x plus 5, and let's go ahead and do this as FOIL. We'll see what happens, we'll look at the pattern, and then that's it for this video. So x firsts, x times x, outsides, insides, lasts. I get x squared plus 10x plus 25. It is not x squared plus 25. You get a middle term in there, okay? And the middle term is not surprisingly 2 times 5. Like 2 times 5 times x gives me my middle term because they were the same. The 5s were both the same on the ends of those. So the inside term, the outside term were exactly the same. And this is a pattern that persists. This was the example I did, x squared plus 10x plus 25. This one, x minus 8 squared. Let's just think it through. X squared, sure. The end is going to be negative 8 times negative 8, which is positive 64. And the middle, 2 times negative 8 times x, negative 16x. That is a cute pattern. Again, not a huge deal when it comes to this multiplying binomials. You can just do FOIL, you can separate it out, do FOIL, do your window panes, you will get the correct answer. But I want you to be aware of what this pattern looks like, so when you're factoring later, it's kind of already planted in your brain. Here's the binomial squares pattern if you want to take a second and write that down. So let's do one more of these. Let's say I had something ridiculous here, like 2x plus 3y in parentheses squared. A binomial square, but variables, coefficients everywhere. We got this, okay? My general pattern, if you copied it down on that last slide, is first thing squared plus 2 times first thing times last thing plus last thing squared. First thing squared, 2x squared. That would be 4x squared. 2 times first thing times last thing. 2 times 2 times 3 is 12. X times y is xy. And then last thing squared would be 9y squared. This is my final answer. That does it for this video. I hope that that's been helpful for you in processing how to multiply all different kinds of binomials. Keep looking for my other videos, and I appreciate you watching.